Good afternoon to all present. My name is Guilherme Guignone and I would like to thank you for this opportunity for one of the speakers at the BIM Coordinators Summit 2023. The theme of the presentation is Lessons Learned from a BIM Coordinator in Airport Engineering and the case study of the engineering project for the passenger terminal at the Maringá Airport in Paraná, Brazil. I will talk a little bit about the lessons learned that I obtained as a BIM coordinator in engineering project based on BIM for Brazilian airports and my role as BIM coordinator at Brazilian Airport Infrastructure Company INFRAERO. I will also talk about the project for the passenger terminal at the Maringá Airport located in Maringá in Brazil. I am architecture, safety engineering, and master in civil engineering. I am also an architect, BIM manager, and BIM coordinator at the Brazilian Airport Infrastructure Company INFRAERO. I am professor. I am also PhD student. One of the biggest challenges of a BIM coordinator is that the promised benefits of using the BIM methodology can be materialized for societies. In this context, there are key elements that define the appropriate strategy for the project and that monitors its execution. Thus, there are three fundamental elements for building the quality assurance of BIM models. First, the pre-design stage, which involves the implementation of BIM in the organization, which includes the diagnosis, planning for implementation and improvement. Second, the post-hiring planning stage, which includes the preparation and validation of BIM execution plan, and the project execution stage, which involves the performance of the strategy materialized in the BIM execution plan and its execute attendance. There are also barriers and difficulties and the need to implement procedures to consolidate good results and mechanisms to improve existing process. A good example of the application of such concept was the project for the passenger terminal at Maringá Airport, Brazil, for which I was BIM coordinator. The three pillars mentioned were worked on exhaustively. In this presentation, I will emphasize steps 2 and 3 active in the project: execution of the BIM execution plan and execution of the strategy. The Brazilian Airport Infrastructure Company INFRAERO was hired to carry out the engineering project for the modernization and of the passenger terminal for Maringá Airport, in Paraná, Brazil. INFRAERO this year completes 50 years of operation. The company has already been responsible for operation more than 66 Brazilian airports. The scope includes the expansions of around 4,500 square meters. The beginning of the contract took place on April 2021 and lasted until the first half of 2023. The contracting party was the airport operator of the airport and the Civil Aviation Secretariat of the Brazilian Ministry of Infrastructure was the sponsor of the project. The following BUs were adopted in the project: discipline models, quantitative service, technical documentation, and interference detection. These BIM uses are mandatory for contracting with the Federal Public Administration in accordance with Brazilian law. In 2021, the Brazilian federal government published the Airport Project Manual. This manual was a landmark for the definition of BIM requirement for airport project in Brazil. The project was the first to adopt the premises contained in the manual and the first BIM project for a Brazilian regional airport. The project is part of a pilot plan for the implementation of BIM in the Brazilian Ministry of Infrastructure. Assumptions adopted in the BIM execution plan. The strategic BIM execution plan was designed to enhance collaboration and ensure the quality of BIM models. The BIM execution plan was developed to be a manual for the project team regarding the BIM procedures to be adopted. It should be didactic and precise. The role and attributions were adopted considering the following premises: clarity in assessment for those who will perform the task and for everyone involved in the project. The BIM Coordinator is responsible for designing the BIM execution plan and for optimizing the quality assurance process of the BIM models. The project coordinator is responsible for the integration between the technical solutions. Role and attributions. BIM models responsible for the execution and review of discipline models. BIM discipline leaders responsible for managing the information of their project disciplines. Project coordinator responsible for integration, technical solutions, and validating the compatibility process. BIM coordinator responsible for the process of optimizing the quality assurance of BIM models. He will be responsible for carrying out in-depth audits on the models with regard to geometric aspects and no graphic information, in depth accordance with the BIM execution plan. In this context, we can highlight some important differences in responsibilities between the project coordinator and the BIM coordinator in the project coordinator model. The project coordinator is responsible for, among others, duties: integration between design solutions, compatibility between design disciplines, project scope control, lead meetings, and among other duties. And the BIM coordinator is responsible for project information management strategy, lead coordinator meetings, validate discipline models, run the federate model, and validate the federation, and among other duties. Meetings. It was important to define some types of meetings, such as kickoff or open meeting. BIM execution presentation meeting. Systems conception and hierarchy meetings. Technical meetings. Integrations meetings between disciplines. BIM coordination meetings. BIM coordinators meetings, led by the BIM coordinator. The BIM coordinator receives the models 1 day before the meetings, validates models, registers inconsistencies in the BCF Manage tool, and lead meetings to resolve inconsistencies. Video conferences are used. critical inconsistencies are presented, ways to resolve inconsistencies, and deadlines for compliance are discussed. There are standard checklists to check for inconsistencies and the use of clash matrix to evaluate the performance of the quality assurance process of BIM models. The fundamental premise was the division of the BCF managed environment into two, BIM Coordinator and Project Coordinator. In the first, only the BIM Coordinator managed the process of issuing and resolving consistencies. In the second, a free flow of communication manager was developed in each group of disciplines. The BIM Coordinator performs audit on multidisciplinary models in IFC and native format and on multidisciplinary models. After the validation and audit process in these models, interference detections was carried out. A priority hierarchy of changes between disciplines and the execution of interference detections was also conceived. It was adopted for building and infrastructure. Clash matrix for building BIM models. Discipline with lower priority for changes in case of conflicts are positioned at the bottom of the pyramid, while those with higher priority are placed at the top. The table shows the steps for performing interference detection between disciplines. For example, column 2, architecture versus structure. Column 3, architecture versus structure. And mechanical system, and so on. Clashing matrix for infrastructure BIM models. The table shows the steps for performing interference detection between disciplines. Clash matrix for infrastructure BIM models. The table shows the steps for performing interference detection between disciplines. For example, column 2, geometry, paving, and sewerage and water system. Column 3, electrical and electronic installation are adapted. Through the model verification checklist and use of the clash matrix, it was possible to standardize the analysis and results and obtain performance graphs of the quality assurance process of the BIM models. These processes were presented to the contracting party in the partial deliveries of the project, demonstrating the methodology adopted, how the process was being carried out, and verification of the quality of the BIM models and the results achieved. This entire process was also documented in a document called Project Quality Report. For the managing of documentation and communication, a document managing environment prepared by the Federal Government of Brazil was adopted, and for the managing of the project communication, a BCF managed tool called BIM Collab was adopted. Reports were generated from proprietary software, model checking software, and IFC viewer software. Inconsistencies were found in the authorial model and simplified conflicts detection in authoring software. and inconsistencies were also found using rendering tools with faster from the native model. Inconsistencies were found in the authoring model and simplified conflict detections in authoring software, and inconsistencies were also found using rendering tools with fast from the native models. Model rendering tools were adopted not only to generate deliverables, but as tools for the quality assurance process of BIM models. They were brought to the meetings providing a better understanding of the models, enhancing the identification of inconsistencies and bringing the definition and resolutions to the discussion regarding the specification of the finished materials to be adopted. The non-graphic information was structured in the form of purpose sets so that the contracting party can better filter the model data in each BIM object. The classification system according to the Brazilian norm was adapted. The level of detail and level of information of the models were adopted in accordance with the methodology of the National BIM specification. Through the graphs of inconsistency and interference, it is possible to verify that there was a significant reduction of the inconsistencies identified in the BIM coordinator meetings, even increasing the number of BIM objects and information. Benefits achieved. With the BIM requirement strategy adopted, it provides improvement in the communication management process, cyclical optimization process adopted through the development of the project, facilitation of understanding of the project development process by the entire team, providing better collaboration and consequently better project solutions. Gradual reduction in the number of the interference and inconsistencies, even by increasing the number of disciplines and levels of detail and information in the models. Less number of project revision being linked to partial deliveries. Inconsistencies were identified and resolved before publishing the deliverable to the contractor. Assertiveness and reliability in communication. Models adjusted with the geometric detail level and information level. I would like to end the presentation with the quote from Martin Fisher. Knowledge is the process of accumulating data. Wisdom lies in its simplification. Often, the best results are obtained through simple and precise strategies. It is important to focus on designing the strategy for ensuring the quality of BIM models and on their proper execution. It's, it's necessary to focus on building models that enable real benefits for building. Thank you.